Welcome to Wildcat Science with Mrs. Haugo. This is Chemistry, Chapter 9, and we are on Section 9.2, Concentration and Solubility. So please find your notes and write this down. Concentration is the measure of the amount of solute compared to the total solution. So how much solute is in the solution? A lot of times you will hear this just qualitatively figured out, dilute versus concentrated. So dilute will have just a little bit of solute compared to the total solution, and concentrated will have much more solute compared to the total solution. Also, concentration can be expressed in other ways. It could be expressed as a mass percent, which is a percent, so between 0 and 100, using the mass of the solute divided by the total mass of the solution. So we can be more specific than just dilute or concentrated. We can give it an actual number, an actual percent. So please write down this equation. Mass percent equals the mass of the solute divided by the mass of the solution, which is the mass of the solute plus the mass of the solvent, and then times 100 because it is a percent. So let's do this. Suppose you dissolve 10 grams of sugar in 90 grams of water. What is the mass percent of the sugar? Please write that down. Okay, so we know we're solving for mass percent, and we know that we need the mass of the solute, which is right here, 10 grams of sugar. And then we know we need the mass of the solute plus the mass of the solvent. So that's going to be 10 plus the 90, which is 100. So there we go. And then times 100. So let's sub in our numbers. So we have 10 grams of sugar, 10 grams of sugar, over 100 grams of solution, because that's our solute, 10 grams plus our 90 grams of water, which is our solvent. And then that's a percent, so we want to times that by 100. And we get 10 divided by 100 times 100, and we get 10%. So the mass percent of the sugar in the water is 10%. So mass percent is pretty straightforward. Another way to show concentration is with molarity. And we talked about molarity way back in Chapter 2. So if you need a refresher, 2.3 is on page 60. And it is the number of moles of solute per liter of solution. And this is very useful in the lab because we know a lot of chemical reactions occur in aqueous conditions, and we know that chemical reactions, moles of chemicals will react with each other, and so it's good to just already have it in a mole format. So molarity, measured in capital M, molarity, or molar, equals your moles of solute over liters of solution. You're probably asking yourself, how does one solve a molarity problem? Well, what you're going to be doing is you're going to be using algebra to solve for the unknown. And if it is in mass, you may need to convert mass to moles or moles to mass, depending on what the question is asking. And if you need to, you will convert the solution volume to liters if it's in milliliters. And the order of these steps always depends on the problem. So let's tackle one. Calculate the molarity of a salt solution with 6 grams of sodium chloride in 100 milliliters of water. Okay, so we always want to think about the problem a little bit. What do we need to know? We are trying to calculate the molarity, And we know that we have 100 milliliters, and that is our volume, and that needs to go to, I don't think I can draw an arrow, liters. And then we also know we have 6 grams of sodium chloride, which is in grams, so that's going to have to go to moles. I bet you can have a lot easier time than me doing that. So how does one convert between mass and moles? Well, first you would need the molar mass of sodium chloride, and then you would do a conversion problem. So figure out what is the molar mass of sodium chloride, and then you'll want to figure out what is the number of moles of sodium chloride. So if you had said the molar mass of sodium chloride is 58.44 grams, and that the number of moles of sodium chloride was 0.103 moles, then you would be correct. So then the next step is we're going to have to convert our volume into liters. So we're going to take 100 milliliters and convert that into liters. So if you had said 0.1 liters, then you would be correct. So coming up here, we converted mass to moles, we calculated the volume in liters, and now it's time to set up the problem and use algebra. So we write down the equation, molarity in molar equals moles of solute over liters of solution. And then we're going to sub in our numbers. So we write down molarity, because that is our unknown, equals, and we sub in our numbers, 0.103 moles of NaCl over our liters of solution, which is 0.1 liters. And if you noticed, it was the total amount of water would be the total amount of solution, because it wouldn't change much when we added the sodium chloride. And then we divide it by the liters of solution, 0.1 liters, to get a molarity of, if you said 1.03 molar NaCl or 1.0 with 2 sig figs molar NaCl, you would be correct. So let's try another type of molarity problem. So for a physical science lab, you need to make 250 milliliters of a 1.0 molar solution of potassium chloride. How do you make the solution? Well, you're going to have to figure out how much potassium chloride to put in there, and then since you don't know how to measure that out in moles, you have to figure that out in grams. So we know we have 250 milliliters, and that is a volume, which is going to need to have to be converted to liters. And we also know we have a 1.0 molar, and that would be our molarity. And then we need to know our moles and convert that to grams. So let's first off convert our milliliters to liters. And so how many liters would that be? If you had said 0.250 liters, you would be correct. And then next up, we're going to have to convert, now figure out the number of moles and convert it to grams. But we don't have any numbers for that, so we're going to have to do some algebra first. So now we're going to set up our equation. So please write down molarity equals moles of solute over liters of solution. And then we're going to sub in our numbers. 1.0 molar equals our unknown, which is our moles of solute, over our liters of solution, which is 0.250 liters. Okay, 1.0 molar equals our unknown over 250, 0.250 liters. And then we're going to solve for our unknown, how many moles. If you had said 0.250 moles of solute, you would be correct. But we're not quite done yet, because if I told you to measure out 0.250 moles of potassium chloride, you wouldn't know what to do. We can only measure it out in the lab in grams, so we have to convert that to grams. So to do so, we know we have 0.250 moles of potassium chloride over 1 times its molar mass over 1 mole. So please figure out the molar mass and the number of grams of potassium chloride we have. So if you had said the molar mass is 74.55 grams and the amount of solution is, and the amount of solute, is 19 grams of potassium chloride, you would be correct. So let's go back and check our problem. It says, how do you make the solution? Well, we haven't answered that yet. Well, we know how many grams, 19 grams, and then we know how much solution it would be. We would want to make 250 milliliters. So what we would do is to make the solution, we put 19 grams of potassium chloride in 250 milliliters of water. Now let's talk about our third example. What is the volume of a 0.150 molar solution if there are 0.075 moles of sulfuric acid present? So looking at our question, it's asking what is the volume? So that's what we're solving for. And we know that we have 0.150 molar, that's our molarity. And we know we have 0.075 moles, and that is our number of moles. So you may have guessed the first step is to write the equation. Molarity equals moles of solute over liters of solution. And then the next step is to sub in our numbers. So we have 0.150 molar equals our molarity, and our moles of solute is 0.075 moles. Well, we've subbed in our numbers, and now we're trying to solve for liters. So we have to get liters on top. So the first thing we would do is we would times by L. Whatever we do on one side, we have to do on the other. So then we want to cancel liters on each side, on this side, and then we're left with L times 0.150 molar equals 0.075 moles. And so we want to get L by itself, so we're going to divide each side by 0.150 molar. So when we divide this side by 0.150 molar, that cancels and we're just left with L. And then on this side, we get 0.075 moles over 0.150 molar. And what is the amount of liters? If you said 0.50 liters or 500 milliliters, you would be correct. Let's look at how the units work out in this fraction. Looking at our units, we have moles over molarity. So we have moles over molarity, which we know is moles divided by liters. And we know that dividing by a fraction is the same as multiplying by its reciprocal. So we have moles times liters over moles. And then we know that we can cancel what's on the top with what's on the bottom, and we're left with liters, just like we have there. So there we looked at three different ways to, three different types of problems with molarity, and then 2 ways to talk about concentration, both with percent mass and with molarity. We're also going to talk about solubility, which is the amount of solute that will dissolve in a particular solvent at a particular temperature. In our next video, we're going to talk more about solubility, and we're going to talk about solubility tables, the factors that affect solubility, solubility rates, and solubility equilibrium, aqueous equilibriums. Okay, see you then. Bye.